All right, so now let's look at some applications. So here we have velocity, right? So we have a particle moves along the coordinate axis, just like we've been talking about, or we've talked about before, in such a way that position is given by this function. So now we have a same thing as before, but now the position function has a trig function in it, right? And they give us an interval, so from 0 to 2 pi, so that's one full cycle of pi, right? So basically in degrees it would be 0 to 360, right? So one full rotation around the unit circle. And so at what times is the particle at rest? Okay, so remember, when the particle's at rest is when our velocity function equals 0, right? So I'm going to find what values for x make this velocity function equal 0. Okay, and remember that the velocity function is the derivative of the position function. So let's do that first. We'll find the velocity function, which is the derivative of the position function. So if I take the derivative of this, all it is just the difference and a little bit of a constant multiple rule. So difference rule and constant multiple rule. So basically we just do these individually. So the derivative of 2 sine of t is just going to be 2 cosine of t. And the derivative of t is going to be, or the derivative of negative t is going to be negative 1. Okay. All right, so that's our derivative, or our velocity function, right? And so now what we want to do is we want to set it equal to 0. Okay, so we're going to say, okay, well, 0, like when does this function equal 0? Okay, and so what we do here is we'd add 1 to both sides, isolate the trig function, right? Okay, then we would divide by 2. Okay, so what we get is we get cosine of t equals 1/2, right? And so remember, then what we need to do is take the inverse cosine of both sides. All right, and so that inverse cosine cancels out a cosine, and so we get t equals cosine inverse of 1/2. And so here's where you would use your trig chart. All right, so on our trig chart, what we would do is, if we're trying to find cosine inverse of 1/2, we would align, we would check on the cosine in the cosine column, and we'd look down and we'd see, where does cosine equal 1/2, right? So we see that it equals 1/2 here at, and since we're dealing with radians here, we're going to stay in the radian column. Okay, so so here's one of our possible solutions, pi over 3. And then, and remember, we're just going from 0 to 2 pi, so I'm going from here to here, and that's where I'm stopping, okay? And so another time it equals 1/2 is at 5 pi over 3. So our answers for t would be from, and remember, this is from 0 to 2 pi, because remember, there's an infinite amount of possibilities where cosine equals 1/2, but that's why they give us this interval, so we don't go on forever, right? Because we could go past 2 pi and get other values, or we could go in the negative direction and get this values where cosine equals 1/2. All right, so our answers are pi over 3 and 5 pi over 3. And those are times when our particle is at rest, right? And we don't have units, they don't give us units, so we could put the word units here, time unit, some kind of time unit, so it could be seconds, days, hours, weeks, months, years, milliseconds. All right, let's run through a similar one. We'll run through a little more quickly on this one. So we're trying to find the same thing, right? We have a particle moving along the x-axis, or moving along the coordinate axis, and then we have our position function. They give us the same interval, which is standard, usually from 0 to 2 pi, although it could change, could be from 0 to pi or pi to 2 pi. At what time is the particle at rest, right? So once again, when the particle's at rest, we're trying to figure out when the velocity function equals what? Good, yeah, that's when it equals 0. Okay, And so first thing we need to do is find the velocity function. So our velocity function is the same as the derivative of our position function. And so the derivative of root 3t is just going to be root 3. The derivative of 2 cosine t is going to be negative 2 sine t, right? Remember, the derivative of cosine is negative sine. And so when I multiply 2 times negative sine, I get negative 2 sine. All right, so that's our function. Now we want to set this equal to 0. Okay, so we want to isolate the trig function. So we're going to subtract root 3 from both sides. And so we'll get negative root 3 equals negative 2 sine of t. Then we're going to divide both sides by negative 2 to get the trig function all by itself. And so we get sine of t equals root 3 over 2. Okay. All right, so then I'm going to take the sine inverse of both sides. And you can go straight to the answer at this point. Like, you can look at your trig chart and get your answers here. So if I'm looking for sine inverse of root 3 over 2, I want to bring up my handy dandy trig chart again. Let me give myself a little better spacing here. Okay, and so we want to look now for when does sine equal root 3 over 2, right? So we're going to line up sine, and we're going to go down, and we're thinking about radians. So where does it equal root 3 over 2? Here, and here, right? And so that'll be pi over 3 and 2 pi over 3. All right. So remember, there are infinite amount of possibilities that give us root 3 over 2 for sine, but we're looking for the ones that are between 0 and 2 pi, including 0 and 2 pi, right? So those are possible values for your solution as well. So motion along a line, same thing. It's just that now we know how to derive trig functions, so we can have position functions that also include trig functions, right? So we have kind of this hybrid situation going on with a trig function, and this is actually just a linear function, right? The root doesn't include t, and so it's just a constant times t, really, right?